looking at exponential modeling with percent increasing and decrease. And I think what you're going to notice today is that there's a lot of common sense in these notes. We model a variety of real world problems that are either going to increase or decrease by a fixed percentage over given units of time. And before we use percent increase and decrease, we need to talk about what percent means. And percent is defined as a fraction with 100 as a denominator. I oftentimes say that it means out of 100. So to find a percent of a value means to multiply the value by that fraction. So in other words, on our first bullet here, it says find 22% of 80. We can write 22% as 22 divided by 100. Written as a fraction with 100 as the denominator. Remember that of means to multiply, so we would take 22 divided by 100 times 80. That's with the setup with the fraction. But if we don't like the fraction, how can we write 22% as a decimal? Matthew? 0.22. And we can multiply it by 80 if you don't like the fraction. If you're curious, the answer to that problem is 17.6. But what we're looking at is how can we write a percent, either out of 100 or as a decimal. So now, if we want to find a percent increase, well, increase means that we are going to have to add the percent back to the original value. And contrary or opposite of that, if we want to find the percent decrease, then we must need to subtract the percent from the original value. This can be done in 2 steps or in 1 step, and we're going to look at both. We're going to try to get ourselves to understand the 1-step method, but again, it's common sense here. So for example, we're getting a car that costs $12,000, but we have to pay 15% tax on that car. And what we want to do is we want to find the total cost of the car after tax. I mean, how much are we actually going to have to pay? Well, we can start here by saying that 15% is 0.15. And we're going to multiply that, the cost of the car, by 15%. So if we do that, 15% times 12,000, or 0.15 times 12,000, is 1,800. That's our tax. But what we want to know is how much are we going to have to pay for that car? Well, we have to take that 1,800 and we have to add that back to the price of the car, which means that we end up paying $13,800 for that car. And that's a good common sense way to do the problem. But if we do have a calculator and we want to, we could do this in 1 step. And what happens is we're taking a part of the 12,000 as tax, and then we're adding it back to the full amount. So what happens is that the full amount is 100%, and over here we have 15%. So if we want to figure out how much we're going to take, or how much it's going to cost for the car with the tax, we take the 15% and we add it back to the 100%, which gives us 150%. 115% is what we're paying for the car, we can convert that 115% to a decimal. And it's going to be 1.15 times our 12,000, and 1.15 times 12,000 gives us the 13,800. Same thing that we got with the two steps. Let's try another one. We're going out to dinner at a fancy restaurant, and the bill is $68. We want to leave an 18% tip for the waiter. How much do we pay in total? Well, again, remember that the $68 is 100%. And then the tip is an additional amount to our bill. It's 18%. So if we add those together, we get 118%. And maybe you don't even have to show that step there. But what we want to do with the one-step calculation then is we're going to take the 118%, which is 1.18, and multiply that by our bill of $68. And when we do that, 1.18 times 68, we end up with our amount that we're going to pay of $80.24. So again, a little bit more common sense type problems, hopefully. If we look at another one here, vegan meals at Tofu For You are on sale for 30% off. So this time, we've got a sale price. What do we do when we're on sale? Bradley? We're going to subtract. So the mixed Buddha bowl normally costs $8.50. How much does it cost with the sale? So since it's 30% off, again, we've got 100%. That's how much the Buddha bowl costs, but we're getting it on sale. So we're going to subtract the 30%, which gives us 70%. And if we can determine what the percent is, we can do the one-step calculation. 70%, 0.70 times the $8.50. Well, 0.7 times $8.50 gives us $5.95. As we flip our paper over, we've charged some money on our Visa card. We've got a $522 bill. Visa charges you a percentage of the remaining balance each year in exchange for allowing you to borrow money from them, called the annual percentage rate, the APR. Our APR is 12%. If we don't make any payments this year, assuming there are no late charges, how much will you owe at the end of 1 year? Well, are we going to be adding that 12% back, or are we going to be subtracting that 12% back? And we're going to be adding it back in. We get charged to borrow money from them. So we've got our 100% plus our 12%. So at the end of 1 year, we're going to have 112%. And that is 1.12, as we write it in the decimal. we're going to multiply that by our charges of $522. And when we do, we've got 1.12 times 522 gives us 584.64. So if we didn't pay any money all year, assuming there's no late charges, that's how much we'd have to pay at the end of the year, or that's how much we would owe at the end of the year. The thing is, if we still don't pay after 1 year, we leave that balance there. If we continue to not make any payments here, what happens is the next year we're going to get charged another 12%. And the other 12% we're going to have to pay on is from our balance that we had from the previous year. And when we do that, we'll end up now with the 1.12 times the 584.64 gives us our final value there, which is $654.80. Notice that I rounded to the nearest cent because our money system is the 2 decimal spaces. And the 6 caused us to round up the 79 to 80 cents. So what we've been looking at here with, again, I hope some common sense problems, is we've been looking at percent increase or percent decrease. And now what we're going to look is we're going to look at percent increase or decrease over an extended period of time, like in the second part of our example above. And we have some formulas for this, and they are remarkably similar to some things that we've already been working on. But just to point out, this means that we're going to find the amount based on some time. A of t is a sub 0. That means it's our beginning or our original amount. And then it's 1 plus p. There's our percent written as a decimal. And finally, t is time. And those are the same values over here in our decreasing exponential model. But remember, when we increase, we add the percent. And when we decrease, we subtract the percent. And this is going to be used for calculating something over an extended period of time. So we'll write an equation that gives the savings S in an account if $250 was invested at an interest rate of 3% per year, then determine the amount in the account after 12 years. Well, we want to know how much savings we're going to have eventually in 12 years. But how much are we starting with? $250. And then, are we going to increase or are we going to decrease over time? Well, if we're saving, typically we're increasing. And it's an interest rate of 3%. And we write 3% as 0.03 to the t. So there's our savings. In fact, I probably should have written savings as a function of time. And now what we want to know is we want to know, well, how much is going to be in our account if we put that money in there and we don't touch it for 12 years. So then this is going to be S of 12. So remember, back in our equation over here, we're going to put 12 wherever we see t. And once we do that, we can type it in our calculator. 250 times 1 plus 0.03 to the oh, it's money here, so we're going to round to the nearest cent, but we end up with $356.44. Really helpful to have a calculator. As we take a look at the next one, if the population of the town is decreasing, so this time the problem even comes right out and it tells us we're decreasing by 4%. And we started with a population of 12,500, and we want to know what's our population going to be in 10 years. So we want to show our model, and then we want to calculate out our answer here. So first of all, we're going to start. We can do population based on time. We're starting with 12,500 people. But what's happening is we're going to decrease by 4% each year. And then we've got a time. So there's our model. This time what we want to know is, well, in 10 years, how many people are going to be in that town? Well, that's when we're going to take our 10 and put it back into our formula, wherever we see t. Back into our function. So it's going to be 12,500 times 1 minus 0.04. Make sure you get the decimal right on the percent. Close the parentheses to the 10. Remember, we're not going to have partial people here. So we're going to end up with, looks like 8,310 people. As we get close to finishing, what if we're given the model already? Can we identify some information about this? It says, given the exponential model, y equals 200 times 0.80 to the x, determine whether this model represents exponential growth or decay. What do you think? Growing or decaying? Bradley? We're going to decay. And Bradley, do you have any idea? Well, I shouldn't say that. You have, what was your thought process behind recognizing that it was decay? And he is really close there. I don't think that the microphone could hear him. But what happens is it's 0.8, not 1.8. So that means that we're smaller than 1, which is a decay. So that means that we're going to be decreasing by a value. And the question is, if you might need to do this, 100 minus what is going to give us 80%? What's that number that's going to go in the box there, Jordan? 20%. So we're going to decrease by 20%. Again, 0.8 is less than 1. That's how we know it's a decrease. And then lastly, what's our initial value, which we used A for? Original amount is how I oftentimes think of that. How much did we start with? Because we weren't given any context, we're just given the formula. Well, if you look back at the formula, our original amount should be 200. That's the A sub 0. Then this is the 1 minus 0.2 to the x. And 0.8 is the 1 minus 0.2. Example 4. From 1991 to 1995, the number of computers per 100 people worldwide could be modeled by this function. Computers based on time, 25.2 times 1.15 t, where t is the number of years since 1991. What's the initial amount of computers? Again, what we're asking for is what's a sub 0 in this formula? And it's 25.2. It's that first value in our formula. Are we going to have percent increase or decrease in this problem? Well, 1.15 is bigger than 1, so that's going to be an increase. And again, when we increase, it's going to be 1 plus something equals the 1.15. So what we're going to add to that is 0.15, which means that this is going to be a 15% increase. And then finally what it says is it says use the model to predict the number of computers per 100 people in the year 2000. Well, one thing that I didn't emphasize when I was reading this is it says where t is the number of years since 1991. 91, 92, 93, 94, 95, 96, 97, 98, 99, 2000. Our time is going to be 10 years. So use the model to predict the number of computers per 100 people in the year 2000. So this is going to be 25.2 times our 1.15 to the 10. And we're going to type it in. 25.2 times 1.15 to the 10. And we end up, in my mind, 102. We don't have a part of computer. 102 computers.